Hey guys, this is Brent Lykins Motorsports. I just wanted to go over an email that I received from a customer. I sent Mr. Charles here a custom cam a couple months ago for his 351 Cleveland project. And every so often we get emails or phone calls or text messages with some positive feedback, and that's always appreciated. And as he says here, hey Brent, want to thank you for your help and patience with my build. The motor runs great with a lot of power. Thanks again. And he goes on to say that he needs a cam for his next project. And I just spoke with Mr. Charles on the phone to get his order for that next cam. And he said that in the past that he's always had 351 Clevelands, and they've always been low on torque on the bottom end. And this cam really turned things around for him. So custom cams are good, and again, it's just always good to get good positive feedback. And believe it or not, you really don't hear back from a lot of customers unless something's wrong. So no news is good news, holds true for a lot of things, but it's always good to get good feedback. So this is why we do cam iterations on the dyno. This is why I like to participate in things like Eric Weingartner's Cam Challenge, and he's got a couple more coming up that I'll take place in. But the data is good, and the more I learn from this stuff, the more I can help you guys out with providing the correct camshaft for your application. So if you remember our project, the 302 Junkie Junk Junior, the little 5-liter junkyard motor that I picked up months and months ago, we're gonna do some more cam testing with that, I think. So I haven't dynoed it since the heads were ported. The dyno's been broke, so hopefully I'll get to do that here in 2 or 3 weeks, as well as get some customer engines dynoed. But I had originally thought about doing this and then completely tearing it down and starting over with a all brand new, really high end iteration. But I think I'm going to do some more cam testing before I do that, and it's just going to take a little bit of research on the cam specs that I need, and that's what this video is about. So we're going to talk about some more cam iterations, and I'm going to get with Mr. Daniel Powell and discuss with him about grinding a couple for me. The issue with the 5-liter, the 302, is the piston to valve clearance is not a ton, and I just want to make sure that we dodge that with a future cam. I'd like to do a little bit more lift, and I'm not saying that lift is the only important thing, because it's not. You could have low lift and a ton of overlap and really cause yourself some piston to valve clearance problems. So those two go hand in hand. But I want to go into this with the most educated selection that I can, and was talking to Daniel with this, and he asked for a couple of measurements. So we're going to go out into the garage and out in the shop and see what measurements we can get for Mr. Daniel. Alright, we're out the shop, got the shop warmed up. It was a smoldering 12 degrees this morning when I took my kid to school, so come out here and turn the heat on. But I've got my little 302 buddy in front of me, and we're going to get some measurements. Been talking with Daniel Powell about having some cams ground, and my plan is to get him on a video conference here after a while and record that for you guys, because we're going to get into some little bit of a theoretical thing and see what kind of cams would work with our 302 engine. This has stock, the factory pistons in it with 4 little eyebrows, and I'm kind of concerned about piston to valve clearance. And I don't want to buy 1 or 2 cams and then figure out that the piston to valve clearance is not going to work. So We're going to get into a little bit of cam math. Hopefully Daniel will be able to use some of his cam design software to show lift versus some different crank degrees, that sort of thing, so we can see where the valve would be in relation to the piston. And we're going to scope out a couple of cams to try. So the goal is to get quite a bit of RPM out of this engine. This engine has ported heads. We have not run it yet with the ported heads. The dyno's been down, so I'll be waiting on that for, it seems like a little bit longer from what I've heard. But want to run it with the ported heads and then throw a couple more cams in it to get some data. So we're going to start. I will pull the valve covers off and rocker arms off and all that stuff, and change our valve springs over to checking springs. This is a hydraulic lifter engine. I don't want to muck up the results, so what we'll do is we'll switch to checking springs to keep the lifter from collapsing. And there's two dimensions that we can get to theoretically back into a cam with the piston to valve clearance that would work for us. Alright, so work is starting here, and we need to pop off the valve cover. I'm just going to pull off one side, and we'll use some socket head screws for holding the valve cover on this one. Just kind of down and dirty. Get it clamped on there, and nothing pretty. So I'm gonna pop the valve cover off, and then we'll see what we're looking at with the rocker arms. Poly locks come off next so that we can get the springs off. So we're gonna pop both rockers off. Card plate makes a nice shelf to lay parts on. Then we're going to use our valve spring compressor, pop these springs off. I don't use anything under the valve, no air pressure, no rope, nothing like that. Usually if you just kind of give it a snap at the very beginning, it pops the locks loose off the retainer, and the valve seal will generally hold the valve up. And put a checking spring on, retainer, and a pair of locks, and then we can switch to the other valve. Got to be careful because a checking spring makes a really good catapult for a valve lock. Same deal here. Pop off valve spring. We'll give it a pop. Just takes a jerk. And then the checking spring goes back on that valve. Alright, so the first test that we can do is how much valve drop we have at top dead center. Our motor's at top dead center right now. Valve drop is basically just from the valve closed position to where it touches the piston. So I'm going to slowly push down on this. Well, that wasn't too slow, was it? There's 100, 200, 210, 216. So our intake valve has 216 thousandths before it touches the piston. Then what I can do is I can reset up here. On a 0 dial indicator. And then we'll push down on this valve as well. 1, 2, so 10, 20, 30, so 230 on the exhaust valve. All right, for the next test, we need to use our rocker arms because we're going to get the amount of valve lift at top dead center. So we're going to put our push rods back in. I'm going to use my light to make sure that my lifter, the push rod, is sitting in the lifter cup. Then we're going to set our basically our lifter preload the way that we would be if we were running the valves. I'll roll this engine over until that exhaust valve or exhaust lifter starts to raise. Put our rocker arm on. Whoops, wrong one. I'm not going to worry about preload right now. I'm just going to pull this down to where I feel it's got 0 preload, and then we'll set our exhaust. So when the exhaust valve or the intake valve starts to close, I'll do the same thing here. All right, then we'll just roll this engine over until we hit top dead center. So on the combustion stroke, top dead center should be both valves closed. So we basically want to be on the exhaust stroke. So that should be our compression stroke, and now we're on power stroke. Then that exhaust valve should start to open, and it does. And I'm gonna roll this engine over until we hit 0 degrees, so top dead center. Bingo. Then I'm gonna set my dial indicator on the retainer. We'll 0 it. And then we're going to keep going in normal direction of engine rotation until that valve is shut. So we're at 0. There's 30, 40, 50, 60, 70. So about 75 thousandths of lift at top dead center for the exhaust valve. All right, so we got our dimensions that we need, and I did check the intake side as well. We'll get all this buttoned back up. There's no need to film putting the springs back on or anything like that. Maybe I will, because it can get pretty hairy at sometimes. But we'll get this done, buttoned back up the way that it was before we started this morning, and then we're going to get on the phone with Mr. Powell and see what we can come up with for some cam specs. Alright, so what ended up happening was my checking springs were just a little bit too stiff, even for a hydraulic lifter. That's one of the downsides of a hydraulic lifter when you check all this stuff. But I ended up checking everything off the push rod, and instead of at the valve, and ended up with 85 thousandths lift at top dead center on the exhaust side, and 100 thousandths lift at top dead center on the intake side. So using that, coupled with some new cam data, coupled with a calculator that shows how far the piston down is down at various degrees based off the stroke and the rod length, we can kind of back into piston to valve clearance, getting away with what we need to get away with. So I had intentions of putting Daniel on the video this time around, but both he and I are going to be gone next week, towards the end of next week for PRI, and he's just swamped this weekend. So what we'll end up doing is a part 1 and a part 2. This will be part 1, obviously. Part 2 will come with probably a screen captured Zoom conversation between me and Daniel, where we go over some different cam selections. So stay tuned for that. Thank you guys for chiming in on this. It may not be super clear what the goals were for this video, but I think it'll become more clear when we get some actual cam talk in a week or two. Thank you guys for watching. Hit that subscribe button, hit that like button, and stay tuned for more videos.